So thank you very much, Ed. So I'm Rakthan Kasma. I'm a final mid student from India. So today we'll be talking about basics of all the reviews and mainly focusing on systematic reviews and meta analysis. So let me just share my screen on the episode. Shouldn't just share my screen once. So basics of systematic review and meta analysis. So if you can see, I have used very different kind of slide. I this might look like some kind of element of science class or ecology class, but it's not. So mainly what we are doing is we are focusing on systematic and meta-analysis here. So basically the introduction first. What we're going to talk about in this whole slide. Yeah. We'll start with the introduction. What are reviews? What are reviews do we have? And now the basic reviews on basic thing about reviews. What reviews are? Then we'll move into a general process, which all the reviews follow. The general thing, the general core process, which all the reviews have to follow to go through the whole process. And how can you start? Like how can a person start with this particular review? Any kind of review. So before we start, I have no degrees in this. I have no PhD, no PhD, no all this is from my experience, and I have quite a bit of publications which actually validates that experience from my side. So that my papers have gone through like through a journal process, through a peer review process, and it is kind of validated. So you can put your questions anytime, and the majority of talks, the talk this whole section will be about for med students and doctors and anyone like anyone who has anything to do with medical health care and it's around those. So just I will use silly examples to like for example to explain a very complex things. There's a lot of literature out there, countless amounts of literature, countless amounts of videos are out there which can talk about all the reviews. But what I will do is different here is कि I will talk about the big things in a very silly and simpler way. So let me just move forward with the introduction. So for the introduction, so what is a review first? We'll look into what are reviews. In short and summarized fashion, it is a summary of scientific papers. So in reviews, what we do, we summarize the evidence. That's it. We summarize papers. So in like for example, let me take an example. For example, what do we mean by summarizing the evidence? So for example, we are looking at, for example, we we are looking into how many traffic accidents are happening from in a particular location. So moving from point A to point B, like for example, there are different routes from moving from point A to point B. It's the road 1, road 2, and road 3. So what we will do is here to see if there are any particular accidents happening along some particular routes, we'll summarize the evidence. For example, we will summarize that as we are going through road 1, we'll summarize the number of cars there, number of shops, number of intersections, so we'll summarize all this. This is the basic while going to road 1, while going to road 2, and while going to road 3, from A to B. We summarize the evidence and we will say, for example, we saw this number of cars, we saw this number of shops, we saw this number of intersections, and so on. This is the simplest form of review which we can call the narrative review. All right. So this is the simplest form of review. So we are summarizing a particular evidence on anything to give us an outcome. That's the simple crux behind this review thing. Yeah. So now this is the classical narrative review, right? So now if I put in some, like for example, I will standardize it. I will say, for example, whoever is going through from road 1 or road 2 or road 3, he will wear a red cap. He will wear, for example, shoes. He will go through walking. So I have put some criteria in. So whoever is doing this summarization, whoever is collecting the evidence, what he will do is he will go through the standardized process. He will wear red shoes. He will wear shoes. He will go through walking. This particular thing is called a systematic review. So I'm systematically doing a review. That's it. I'm systematically doing a review. That's a review. Now, what comes after that is we can do a meta-analysis after that. So, whatever data I have from this road one, I want to compare it with the road. So while this comparison is happening, I will call this one a meta-analysis. As simple as that. So we can come into these three reviews. This is a narrative review, a systematic review, and a meta-analysis. We can move forward into a network meta-analysis. We can move forward into umbrella reviews. So as far as summarizing evidence in healthcare, obviously we'll summarize, as far as healthcare is concerned, we'll summarize scientific papers here. As simple as that. So for scientific papers, we will summarize we will summarize the evidence. So as far as healthcare is concerned, we have lots of different like evidences, which starts from weakest to strongest, which is kind of given in this hierarchy of evidence pyramid. So like anytime any kind of new report comes in. So for example, we had COVID pandemic back 2-3 years back. So the first reports that came in were there are a couple of treatments which are working in these patients, like we had ivermectin, we had hydroxychloroquine. So they were just giving a simple case report. They were the doctors were doing they have a lot of experienced doctors. They were giving a particular fact that was working. So they just reported that particular case and they gave us that case report. That case report will be the weakest amount of evidence we have in scientific literature. So those case reports move into opinion articles. So now doctors are starting to write opinion articles. So my opinion is this, my opinion is that. After that, they will move to letters. They will move to animal trials. So what they will do, they will use this particular drug in animals before using in humans. So this is the evidence pyramid. It moves from basic case reports to animal trials to observation studies. So we have observation studies with intervention. So there will be no intervention here. There will be intervention in these kind of observation studies. So this is the basic like hierarchy of evidence that we have. This is the evidence that we are going to summarize in a systematic review or any kind of review. So as you can see on the top of this evidence pyramid, that means from bottom to top, the top is the strongest reliable evidence. Those will be the all our reviews that we have, which will come from systematic review, meta-analysis, you're doing a network meta-analysis, you're doing a umbrella review, you're doing a different kind of reviews. Huh? So the reviews are basically the strongest evidence that we have. So now how to do, like, let's move more into this reviews. Huh? So this is a kind of a pyramid for these reviews. So most basic reviews that we have are literature review or narrative review. We simply have a narrative, we simply want to prove something. We gather whatever amount of papers that we have, whatever amount of papers and we'll try as like whatever evidence we have, we'll summarize that and we will prove our narrative. We have a narrative, we have a question. We prove that question and narrative using papers, which we'll get from different sites and we'll get into that. After that comes scoping reviews. Just leave this for a moment. We need systematic reviews in my data. Like, as I was telling you, systematic reviews are basically we put in certain criteria. Like, we have to go through certain 1, 2, 3, 4. We have to go through a checklist to come to a particular result. So we cannot just pull out whatever papers we want and we can just present our studies. We have to go a certain system which everyone follows to get through that result. So for example, if I wanted to prove, I gave an example here, like we want to go from step A to step B to step C. We will use a criteria that he has to wear this, he has to do this, he has to do this. That will be a systematic way of doing something. So what the idea behind this is, if someone follows my system, for example, I have a research question like apples cure cancer, for example. It's an example. So I will follow a particular system, and if someone follows my system, he will get the same result that I am getting. So for example, if I am saying is apples do cure cancer. So what will happen is if he goes through the system that I have followed, that I have created, and he will get the same results that I have. No? Yeah. Right. So that is systematic review. Now we come to into the basic of meta-analysis. In meta-analysis, we compare. Huh? In network meta-analysis, for example, if we are comparing drug A and drug B and drug C and whatever drug D. Yeah? So we are saying, now let's move forward into the general process. So this will be a general process for all the reviews. All the reviews will have to go through this process to like get to the results. So this is the general process that we'll explain. I have put in the memory hooks after this. So this will make everything easy. 1 second. So all the reviews will like start from a research question. First, you will have a research question. You will go through a research question, and you need to have expertise on certain, you need to have a background to have a research question first. So after having a research question, now you need to have papers to answer that particular research question. We will get those papers from. So you will look into different databases. So for answering that particular research question, what you will do, you will format, you will make a set of keywords, and you will use those keywords and to pull out different papers from different databases. Right. After pulling out papers from here, formulating a search strategy that's what we call a search strategy. We we put in different keywords into different databases and we pull out papers. That's what we call that's what we call developing a search strategy. Right. After pulling out all the papers, we'll have different databases, right? So for example, what databases are actually, they are like, for example, Google in the search world. So it's kind of a Google in the search world. So we have different these search databases, like we have Google, we have that Bing, we have Go, and something like that. Similarly, we have different, this is what we call the search databases, like for example PubMed, we have Cochrane, we have MBase, we have SciMed, we have different kind of databases, Escobar, and there are different kind of databases. What we can do is we can put a set of keywords, like a set of lines in there, and we can pull out whatever papers are required. After pulling out the papers, we will remove the duplicates. For example, it's the same thing, like we want to search something from Google. The same things can come out from, for example, Bing. So the same thing, if we pull out some certain amount of papers from PubMed, the same number of papers can come out from some other database like Cochrane or something like that. So we'll put all those papers in a software and we will remove the duplicates, as simple as that. And after going through removing the duplicates, we will go through a screening process, right? We'll go through a screening process here. So we'll screen our papers. So whatever papers we will have, we'll have to screen those. We will have to see if they are answering our research question or not. We will get into each point in a bit. So after that, we'll do the quality assessment of those papers. We will check the quality of each paper. We'll extract whatever data we need from those papers, and we'll write a manuscript. All this process I have summarized into this memory hook, right? So if you know how to catch fishes and cook fishes, you will know how to do this. That is a simple premise behind that. So for example, for catching fishes, you will not go to a supermarket, right? Here you have to know how to build nets, and you have to search for ponds. So as far as nets is concerned, net will be your search strategy. Fishes will be your paper, and ponds will be your databases. So there are different ponds in non-research world. Like we have Google. Google is one pond. Bing is one pond, and different kinds of ponds we have. Similarly, we have research ponds. Like, I'm just making this term out. There's nothing like research pond. I'm just telling you pond is a database. So we have databases such as PubMed. So we'll build our net that is the research strategy. We'll build a net. We'll throw in different ponds, and we'll catch fishes. Fishes will be our papers, right? So obviously, while we're throwing the fish net in, we'll catch fish and we'll collect some garbage also. So that's where the screening phase comes in. We will remove the garbage out and we keep our fishes. That's the screening phase comes. That's where the screening phase comes up. So after that, we'll check whatever fishes we have. We will check the different, like for example, we have different tuna fish and we have carp fish and different kinds of fish. We qualitatively appraise them. We'll say that like this is a high quality fish. We can make a particular dish from this fish. We will appraise the we will divide the fishes on the basis of the quality they have. That is where the quality appraisal part comes in. After that, we'll extract everything from our fishes. For example, we only want to cook, like for example, the tail part. We only want to cook, like for example, the body part. That is where the data extraction will come in. We'll put different kinds of things in there, and we'll extract whatever kind of whatever taste we want to extract from our fishes. And at the end, we will write a manuscript. So let's now move into the first part, which we will be building a search strategy. So you have a research question, for example, like for example, there's a new scientific discovery. You want to, lots of doctors are seeing like they're giving, for example, 10 apples every day to cancer patients, and they are seeing cancer is actually improving. Yeah? See, this is our like there's a lot of evidence out there which proves that there are case reports, there are scientific studies, there are observational designs which are proving that apples are curing cancer. For example, it's an example. Now what we will do is we summarize the evidence. We have a research question, apples are curing the cancer. We summarize the evidence. First thing we'll do is we will build a search strategy around this. So for that, we know that we have apples are curing cancer, right? So this is a research question. We will divide this research question. So what you can do in research, building a search strategy, you can build it yourself, like I do. You build it yourself. You can build it yourself, or you can give it to librarians, or there are some other methods which I will come and do later. So what will happen is that whatever research question you have, what the librarians tell us, they ask us to put that particular research question in a framework. There are different kinds of framework out there. Like for example, there are accurate. These are all like for example, PICO. We have different PICO. We have PICO. We have PEO. We have PO. There are different kinds of frameworks for this. So what these actually stand for? This is a population. P stands for population. I stands for intervention. C stands for comparison, and O stands for outcome. So what this framework does is it makes very easy for us to like do the whole review thing, starting from the search strategy. It will help us a lot in doing the search strategy part. Let's come to, for example, for PICO format. It's the same thing for PICOT. So it's population, intervention, comparison, outcome, and time. So what it's telling is like for example, population of our research question. So our population of our research question is cancer patients, for example. Intervention is we are using apple. So it may be apple in form of juice, maybe whatever in tablets, whatever form. That will be intervention. And our outcome, we like for example here doing this for cancer patients, right? These are skin cancer patients. So we are telling, for example, if the skin turns from red to blue, we are saying the cancer is cured. So what we are looking for? We are looking for blue skin patients. Like we are looking as an outcome that our particular skin cancer has turned, the skin has turned from red to blue. We are saying that this is a cure, this is our outcome. We are looking for this outcome. So now what we'll build a search strategy around this. Now we have the PICO. You don't need to have like, if you have a full PICO, you don't need to have comparisons like always. You can have comparison, you cannot have comparison. You can have intervention, you cannot have intervention. You can put your research question, in any of these frameworks. That is for PICO, all these frameworks. What these frameworks will do, this is make our things, this will make our job very, very easy. So moving into that, for example, for the search strategy, you're using the PICO method first. We have a PICO format. We have put our research question in the PICO format, and then we'll build a search strategy around this. So let's just take a real life example for a second. Let me open the PubMed. We'll try this in a PubMed also. So what we will do is, for example, we cannot just go into a database and we can just like directly type into apples. We cannot put we cannot directly put this, although it's giving us support on whatever it is. We cannot go directly into search in any database and like put a question like that. we need to divide a research question in that Pico format, in any kind of format. So what I will do is I will divide into the Pico format. So what I will do is this one is I have the population, I have the intervention, those are the apples, I have the outcome, right? What I would do also is I would use the Boolean functions. So there are special kind of keywords that we use. Like for example, we use and or and not. These are Boolean functions which are used in different databases. We can also use them in Google, but these are mainly used in research databases. So what and will do, for example, I'm looking for papers. I'm looking for papers which should have an apple word in there, which should have a cancer word in there. I need to have both of these words somewhere in the paper. So I will do the I will use the and function in between. So I will use, for example, if I go to PubMed, I will use apple and so it will only give me papers which will have both these words, apple and cancer. You're seeing I'm getting around 300 results. So now if I want one of the words to be in the papers, I want either apple, I want either cancer or both. It doesn't matter to me. I, I do not need like both words to be in a particular paper. I would definitely use an or. So that was an and. So I need both the keywords to be in the paper. Now or I need either apple or cancer to be in the paper, or if the both the keywords are in the paper, or I will use not. Not is one other Boolean function. So I have to not. But not does is it makes sure I have those papers which have apple in there and not cancer. This particular word cancer. So if you can go through all I'm seeing is apple. I'm not seeing anything related to cancer. So I have directly put in this one like I need apple word in research paper. I don't need cancer word in research paper. Now if I put in apple and only give me papers which will have both the words. So apple and cancer. Something is talking about apple and cancer. We're talking about apple and cancer. Apple and cancer, right? Apple and cancer. Obviously, this is a file system, but obviously it will not be 100% correct each and every time. It will try its best to like give me all the papers which are talking about apple and cancer, right? So apple and cancer. They're talking about apple and cancer. And if I use or, so it will give me any kind of paper which it will give me any kind of paper which will have or the word cancer in it. So now what I will do, for example, apple and cancer, we have both the words here. We have only apple word here. We have only apple word here. Both the words cancer, apple, cancer, so how I will use this Boolean function? The Pico format we had. So in our research question, so whatever papers we are looking into, we have put our research question, we have put our research question in a Pico format. In this Pico format, we have explained that. Now what I will do is I will put my population first. I will take out all the synonyms from my research question. That whatever population I have, for example, I have cancer patients. So I have melanoma patients. I will put names of different cancers in my population. So whatever types of cancers I have, I will separate that with an or. That will be cancer or melanoma or whatever different cancers that I have. I will put this one term under the population. And I will separate all my synonyms with an or. So whatever type of population that we have, we'll separate that with an or. Whatever type of intervention we have, we will separate that in a particular bracket. Intervention, for example, we have apple. The apple juice. We have apple tablets. Whatever different. I know this is a silly thing, but just as an example. All different examples, and right, all different interventions that we have. And we'll see different outcomes that we have. We will all separate those outcomes within or. And we obviously need all the papers which have this intervention, which have this particular intervention. We definitely need those papers which have our population. We definitely need those papers which have our outcome. So what we will do, we will AND all these. We will AND the population with the intervention with the outcome. So what I am telling you once again, will add the population. So whatever, like for the population will be mainly cancer patients or any different other patients. Whatever terms we have for our population, right? Put that in bracket, separate with an or, and we put an and in between these two. And now we come go into our intervention, which will be apple, or maybe apple juice, or any debate. Any different kind of intervention which we can like take out from our research question. Obviously, we need to have expertise. We need to like know about what you're trying to find. And we try and we add and we kill, and we go into the outcome first. So we have our P, the cancer patients. Whatever terms we have related to our cancer patients, whatever terms we have related to our population, those all we separate with an or. Same for the intervention and same for the outcome. And now we put this in a database. In any kind of database, we can again find our search results like this one. So we have maximum possible chances of, because we have built the research net now. We're throwing different points. This is where research net. The search strategy, like for example, this simple search strategy we have built here. If we can go into some examples of search strategy, right? Okay, yes, I can. We have an example of such strategy here. So these are COVID-19 patients. Like COVID-19 patient ICU and mechanical ventilation patient. This particular item. So for so what they PICO here is that they only have P and O. They don't have anything else. They have population that is COVID-19 patients, and they are looking at outcomes, like for example from ICU outcomes, mechanical ventilation outcomes. So if we move on to their, for example, their search strategy, which they have put into different databases, like this one here. Here's the search strategy. It's the PubMed. Their first database was PubMed. Their first bond was PubMed. This is the search string that had developed. The search strategy to the main net that they have developed. It's the same thing. SARS-CoV-2, and they're talking about the population first and the outcome. They're adding the population with the outcome. Same thing they've done with the Scopus. Same thing they're in something DHL. And these are pre-med databases. They've used 4 different databases here, for example. They're putting the search strategy. They're doing the same thing in different databases, right? So this is the search strategy. Once again, compared to the KL. Same thing, the net will be a search strategy. We form a search strategy, we'll form a net, we'll put in the different bonds, we'll get our papers, we can get our fishes. So the PICO we are developing, it is very important because PICO will help us in everywhere. If we have PICO in the first, we have made up here, this is a PICO in the first step. The PICO will help us in every other step. The screening, quality appraisal, data extraction, writing the main paper. So after throwing the, searching different bonds, building a search strategy, taking out like fishes from different bonds, we can move on to the second phase with the screening flows. So we were looking at this example, for example, from this apple and this cancer thing. So we have different kinds of papers. So all of these papers will not answer a research question. The same thing, like we have been catching fishes, there will be the garbage in there. We have to remove the garbage, so on. So what we'll do is we'll go into screening phase. We have 2 different phases in a screening phase. So whatever papers we have at first, we will go to 2-step process in this screening phase. We will do a title and abstract screening first. And after that, we'll do a full text screening post. So it starts from title and abstract screening, then to full text screening. So in title and abstract screening, we will directly read. So what happens in most of the reviews is, like for example, when you put different search strategies in different databases, like 2,000, 3,000 papers come out. So you cannot go through each and every paper and see if it's answering the research question. What we do is we make it easy. We will read the title and abstract only of every single paper, and we will see if it's answering a research question or not. So we'll read the title of each paper, and we'll read the abstract of each paper. For example, we have this paper here. this one. So we will do the title. So if it is like talking about such stuff, file HTML obvious. So, and abstract, yes. They're definitely not answering our research question or the apples curing cancer only. It's not answering our research question. So we'll definitely include or exclude, or we'll put in maybe. How that process will happen, how the screening will happen. The first step is title and abstract, second is full text. Title and abstract, will the title, will the abstract. We'll decide if it's included, the paper is included in our process, or it's not included in our process. To do that particular thing, like to check the title or abstracts only. So whatever papers we have collected, we'll do two things with the papers. We can do two things. We can either use a classical method, like we can build a sheet, like for example, we'll build a sheet, we'll put our first paper, like for example, paper was first from some author, and author. We have two papers, for example, right? So from so after taking it, like for example, taking each paper, taking all the papers out from the databases, what will happen after this? Each step will be done by two people. So for example, I am biased for my research. I want to like answer it in a particular way. So what will happen? Each and every step after collecting the papers will happen, like two people will be doing the same thing. So what I am done in this, for example, this will be the first paper. I'll put in the paper. I'll put in the like the DOI, the identifier of that particular paper, the link to the particular paper, and I will check that particular paper for this is the first step. This is the title and abstract screening, TNR screening, TNR screening. So I will put in the paper. I will check the title and I will check the abstract. I will see if it's answering my research question. Now how I will decide if that particular paper is answering my research question. That depends. Will form an inclusion exclusion criteria. So for example, we know like in this kind of cancer patients, what happens is I will have to build an inclusion exclusion criteria. For example, I'm only taking a particular amount of papers. I'm only taking case reports, for example, or I'm only taking randomized control trials. So I will put that in this is my inclusion criteria. My inclusion criteria is I will only take these kind of papers. I will only include these number of researchers, and there has to be a reason for that. There has to be a reason for that. You have to like explain like why are you putting this particular inclusion exclusion criteria in your screening. So for example, I'm excluding papers from back from 2010, for example. I'm only taking papers from 2010 to 2023. So this is my inclusion criteria. I will build an inclusion exclusion criteria. And according to that inclusion exclusion criteria, I will do the screening. First for title and abstract screening, I will just use a title. I will just use the abstract. And based on that, I will just say like if this is answering my research question or this is not answering my research question. As simple as that. After that, I will move in the full text screening. So this is one of the we have two-step process, title and abstract screening, and we have full text screening. In the full text screening, we will read the full text. So from title abstract, we will read many different articles, which will read the title. We'll see like it's not answering a research question. So at start we will have like a good amount of papers, like in thousands. We'll have 2,000, 3,000, or even 10,000, 50,000 papers. We will hit an abstract. We come down to we exclude a good amount of papers just reading the title or just reading the abstract. The title and abstract, which are not the right question, will come down to we will funnel these papers down into the full text screening phase. So we'll have a less amount of papers in this bowls because we have already excluded a lot of papers just reading the title and abstract and seeing if they're answering the research question or not. So we'll now on the full text screening. It will happen in the same way. Two authors will come in. Two authors who will what will do. So what I will do, I will make two sheets for this one. So one sheet I will put in. So because I'm blending the first author from the second author. So if first author is saying include this paper, then he will give a reason for that. For example, this is my exclusion criteria. If I'm excluding a particular paper, so I'm saying for 0 for exclude, 1 for maybe it's including or not, proof it, we have to include this. So I'll put a 2 here. So I am including this paper. So I'll put a 1 here, like I am excluding this paper. So I will give my reason for that in next column. Same will happen for the second author. I will form a different sheet for this author. So there's like he does not know like if I included the paper or excluded the paper. So then a third author will come in and he will check uh, if both authors are saying yes, include the paper, we will include the paper. If both authors are saying they'll exclude the paper, we'll exclude the paper. So if there is a conflict between paper, one author is saying like include this paper, the second is saying not, we have to exclude the papers. We can do two things here. First thing is we can ask them, they can like meet up and they can say like what are the reasons behind their excluding the paper, they're including the paper. They can come to a conclusion like we are taking the final decision, but taking while we're excluding the paper. Or a third author can come in. A third author can give a judgment like we will include the paper or we will exclude the paper. So we will get a final amount of papers from the screening phase, right? So these were the fishes, there were a lot of fishes, there's a lot of garbage in there. We moved that and we did the title and abstract with the full text screening. And we got the main crux of our the main papers that we have, from which we'll answer our research question. Those will be the fishes. So this will be a two-step. We will have to form an inclusion screening criteria for this. On the basis of that, but we will decide if we have to include this particular paper. For example, I'm taking only adults, so I will put in inclusion screening criteria, only adults. The papers which are talking about adults, I will take only those papers, those particular papers. So this process was done classically in Excel. So what I will do, I will form two sheets. This will be the first sheet, and I will form second sheet from this one. Right, I will do the same thing here. I will remove all the information from the first author. I will this will be from second author. So I will do the same thing for first author and second author. These will be independent of each other. So the first author does not know what the second author did, or vice versa. This used to happen classically in Excel sheets. This was a time like it used to take a lot of time doing this in Excel sheets. Now what we can do is we can do the same present Ryan. With a software, with a software, this is an online software which we call Ryan.ai. So what can happen here is like, for example, we had a narrative review on COVID-19 vaccine hesitancy in South Asian countries. So what we did is after doing the full text screening, after collecting the papers from different databases, we put all those papers in Ryan directly. If I can choose a paper in a second. No. It happened for this paper in here. And this is the narrative review that we did. Same thing that we did. We are collecting the papers. We move the papers into the Ryan. The same thing. So this is the Ryan actually, and I didn't give it. So you can see many different authors have given their decisions. This will be independent of the author, the blinding will follow it. So one author will put in his decisions, and so on. These are the final included papers. The different authors they excluded. They have given the reasons for the exclusion. The wrong population type. This is a review article. So we did build a inclusion criteria for this. For example, we are not taking papers from. So this is the paper vaccine hesitance in South Asian countries. This was a simple narrative review. It's not a systematic. It's a narrative review, simple narrative review. What we did here is we don't want any population outside South Asia. So if any if any paper is talking about the United States, for example, we are removing that paper. This one will happen for the screening. The first one was for title and abstract screening. So you can see these were around 300 papers we had here. So it's difficult to go through all the 300 papers. It's very difficult to go through the full text. So what in the first place we read the title, we read the abstract, and we say like if it's included in the paper or not. And after that, we move into the full text screening phase. If I may once again, the full text screening, we had a total of 104 articles in the full text screening phase. Same thing will happen here. I will give a particular decision on this paper. So I will include this or exclude this. How the rayon works, it's a different, but it's a different thing. It will take definite, like we will have to move more into that. How the rayon works, we'll not talk about that particular part yet. So these were this was the full text screening now. So we were going into each paper, right? If I go to this particular paper, I will read the full text here, and I will see if it's talking about vaccine hesitancy and if it's talking about the South Asian population. Right, I will go to full paper. It's a screening phase. Full text and title abstract. After the screening phase, this was done first in Excel, and now there are different softwares. Like there's Ryan is out there. There's one other software which we call Covidence. We can use that one also for screening. The screening phase, you can see this process of screening. This can be represented in a diagram, which we call Prisma diagram. These Prisma cards are actually which have made the criteria that I was talking about. For example, if you're doing a systematic review, these Prisma people have they have put in a certain guidelines. For example, you have to do this in a review, you have to do this in a review, this in a review, to make it a systematic review. So as for the Prisma diagram is it will like summarize the whole screening phase. Like for example, this one, we had a Prisma diagram for this narrative review. So what I'm doing the same thing. We took papers from PubMed, 136, from Science Direct, this much, from Sinha, whatever. So we put those in Ryan. What the Ryan does, it checks if there are any duplicate papers. So there were 101 duplicate papers, as you can see. We put those into the screening phase. This one is screening phase. For the title and abstract screening, I transferred all the papers into the Ryan. We did the title and abstract screening. We just wrote the title. We just read the title and the abstract, and we judged on the basis of our inclusion exclusion criteria if we have to include this paper or not. So we excluded 277 papers in the first part of screening, the title and abstract screening. Then we moved in the full text screening. Now what happens like in the full text screening phase, we have to get the full text of the articles. That may be possible sometimes, that may be possible not sometimes. We will find full text for some papers, we may be not able to find full text for some papers. So that is where the if we could retrieve the articles, that's this particular these two particular boxes are talking about. So we were able to pull out 98 full text articles from whatever articles we had. So 6 we were not able to retrieve. There might be some problem with the papers. The paper was like excluded or something. This is the full text tracking abstract and the full text screening. On the full text screening, we will check our exclusion criteria. So these were our exclusion criteria right here. So we were not taking any survey based studies. We were not taking any studies which we did not have any like vaccine hesitancy as a primary outcome. All the studies which were not in South Asia, right here. So we had 10 studies we were not in Southeast Asia. This is our exclusion criteria. But we are putting this in a Prisma diagram. We are showing this as a summary. So in total we had 18 papers after our full text screening phase. So we have gone through screening phase. This Prisma diagram, this will give us a summary of our this screening phase, starting from title abstract to the full text. So we collected our papers. We went into the screening phase, and we have a total of 18 papers now. So after screening phase, we'll move into after collecting the whatever fish we have. So we are back on the fish business. By collecting our fish, we have removed the garbage. Now we have to qualitatively appraise the these fishes. Like we have to say like this is a good quality fish, this is a bad quality fish. This is a good quality paper, this is a bad quality paper. There are certain different criteria on just doing the quality appraisal. So what we have is we have a different checklists or scales around this quality appraisal. For example, JBI, this is Jonas Big Institute something. They have put in different checklists for example, we have case reports, or we have RCT, or we have different observational studies like cohort studies. We have case control studies. They have put a checklist. So if a randomized control is doing A, B, C, D, they will say like this is a good randomized control trial. So if a case report is collecting, it's collecting birth rate, it's collecting treatment options, it's collecting this, and it's collecting adverse effects. If a case report is doing that, we will see yes, it's doing this, doing that. They have given us a checklist. For example, JVI values. The Casper, we have Casper checklists. We have checklists from NIH. Same thing, we have checklists from Cochrane database. So like, let's move for example in JVI checklist once again. So the JVI research checklists. In the squad cohort study. Special bits. For case reports, we say. So if I download a checklist for case report, the same thing. This will happen with two people have to do on one paper. The same thing. The screening phase. Each paper was screened by one person, by 2%, and if there was no consensus in between those two persons, third author will come in and he will judge the paper. Same thing will happen in the quality appraisal part. We will check the quality of paper. One person will check the quality of paper, then second person will check the quality of paper, and they will give their quality appraisal. Like, is this a good quality paper? Is this a bad quality paper? On the basis of these checklists. For example, for case reports, we have different research designs. Like we have case reports, case series, cohort studies, quality researches, and MS control trial. Different type of case report, different type of research designs. Or whatever research design, we have a different checklists. Maybe from JBI, maybe from Cochrane, maybe from all different kind of institutions. Let's take for example for JBI, they have given a checklist for case reports. So if we have included case report, if we are including case reports in our particular systematic review, to check the quality of that particular case report, we'll go through this checklist. For example, this particular checklist has 10 questions in there. So we have to check each case report. We have to read the case report. We have to see if it's answering this particular question, this particular this question in this checklist. So we will judge this out as yes, no, unclear, or not applicable. Now, how that is done, I will transfer this checklist into an Excel sheet. Same thing that I've done here. Copy this. The quality. This one was for the case series. This is the question number first. Question number second. Question number third. I will do this for two people. I will duplicate this one, and this one, for example, I am doing the first pass. I am doing the first pass of all the papers. For example, we have first paper, we have second paper, we have third, or whatever papers we have. These will be for case reports. So now I will put in, so one will, so I'll put in kind of a code for each answer. I've directly transferred this one from the so the whole checklist I've transferred it there. This one, the first question, I'll put in, so 1 will be for yes, 0 will be for no, 3 will be for yes, and 4 will be for not applicable. Same thing I will put in one research paper, and I will check all the questions. I will put in yes, no, whatever it is. So this will be done by two authors. First author, the second author, to prevent any kind of bias. For example, I want all the papers in my systematic review, whatever review I'm doing, I want those to be of a high quality. This is my bias, this is my personal bias, because I want to put this as a high quality evidence. We are summarizing high quality evidence. So I will say, like, I'm kind of a bias for my research question. I will put everything is high quality. I will identify as high quality. This is a high quality systematic review. That's why I need a second author who will like judge my papers without bias. We have two people judging same papers and giving their quality appraisal. So at the end we will see, like, we will put a criteria here. So there are no nobody tells us, for example, if we have 8 questions here, so if if we have 5 yeses here, then if it's a good quality paper, bad quality paper, it's a medium quality paper. Nobody is giving us that criteria. Or like, for example, if 8 out of 5, if if 6 questions are answered as yes, is it a good quality paper? Or if 5 questions are answered as yes, nobody, we will have to build that. For example, we will say if we have 3 essays from the paper, we say it's a poor quality paper. If we have like 4 to 5 essays from a paper, we say it's a medium quality paper. If we have like 6 to 8 essays in the paper, we'll say if like 5 questions are coming, if 8 questions are coming as yes, we say it's a good quality paper. Or 7 questions are coming as yes, we say it's a good quality paper. We'll build that criteria ourselves. We put that criteria in our paper. So same thing will happen for 2 people, right? So like, for example, we have second pass. For example, from we have a different guy. We'll do the quality appraisal for all the papers. He'll put in the whatever decisions he has. He'll put in those. So what happens? A third author will come and he will check, like, if the first author is like first author is agreeing with the second author in all the questions. So if for example they are not agreeing this one particular question for one particular paper, third author will come in as a final decision maker. He will give a final decision. Or what he can do, the first and second author can talk between themselves and they can come up with a with one particular decision, yes or no, or unclear or not applicable. Or a third author will come in. He will give a final decision on that rule. This will be the quality appraisal part. All this theme will happen for all the papers. So we have quality checklists for randomized control trials from different institutions like JBI. I was talking about Cochrane. We have this another one, this Qabsa tool. So same thing will happen. These make these quality appraisal sheets for randomized control trials. So same thing will happen here. So we transfer all the information they have into Excel sheet. We'll make 2 different Excel sheets for first or the second author, and we'll appraise on the basis of whatever they have given us for randomized control trial, whatever questions they have, whatever scales they have, whatever they have for the randomized control trial. Same thing will happen for maybe you have included course studies, maybe you have included case series, maybe you have included different type of studies. So this will be the quality appraisal part. We'll move to the quality appraisal part. So we have moved into research question, on the search strategy, pulling different data papers on different databases, screening those papers, remove duplicates, screen those papers, add an abstract, full text screening part. Then into the quality, checking the quality of these papers, how many are good quality, how many are bad quality. Now we'll move into the data extraction phase. What we are extracting from this particular from, like, for example, if I want to prove we had this cancer issue, apple and cancer. Now I'm saying, for example, 10 eating 10 apples a day will cure the cancer. In the 10 apples, I know to answer this particular questions, I will have to extract the number of apples that were given. So I know for my particular research question, I will have to extract the number of the apples given, the time that apple was given, the concentration of those apples that were given. So this is the basic theme around this data extraction phase. You have to know what you want to extract. The same thing, you want to cook a fish. You need to put in right amount of ingredients. You need to put the right amount of part in of that particular whatever dish you are trying to make, whatever is the question you are trying to answer. You need to pull out the data. So in short, like, for every research question to be answered, for every systematic review, for every recipe, we have different recipes. Like, for example, we will extract different kind of things, different kind of data from each paper. So, like, for example, let me put this into context once again. So we had a paper, for example, on this syndrome in Bartter syndrome. It's a nephrological disease, right? So I know as someone who has this question, who has a question in mind in the back of my mind, like I want to summarize evidence on this particular disease. So what I will do, we did the screening, we did everything. This is an abstract of the papers recently published. So what I will do in data extraction phase, I will extract all, I will extract that particular data which I will be needing to answer this particular question. Like for example, if I open the data extraction sheet for this particular research, one second, give me a second. And when the data extraction sheet. As you can see, in the sheet with the data extraction sheet is a real example from the data extraction sheet. So I know, for example, in Bartter syndrome, we have the birth weight is important, the genetic makeup is important. If we are doing the genetic tests, what the particular patient presented with. I know that this thing is important in the Bartter syndrome patients. I know the daily treatment options are important in the Bartter syndrome patients. So what we did was we only took case reports and case series here. We included with the papers which are only case reports and which are only case series. Now for building the data extraction sheet, this one is for example for the one particular person. This is the one particular paper on this is the case report. I was the data collector for this one. So I'm putting this one as the first author for this paper. This is a general. We will still use the PICO here. We will get back to PICO. For PICO, this one was our population is Bartter syndrome patients. Our outcomes will be different. We will use different treatment options. Our outcomes will be based on which country that particular patient came from, what treatment did he took, what genetic tests did he did. There are different types of this Bartter syndrome. There are type 1, type 2, type 3, type 4, type 5. I'll have to extract that particular information from my case report. So I need to have a prior knowledge of what I want to extract and what I want to present. It's the same thing. There's a data extraction sheet for this particular systematic review. So I'm using the information for population first. I'm using the PICO. I'm taking the information with respect to my population. So whatever was the country, like this particular case report came from Kuwait. This was the case report was a male gender. So this was the age. This was the birth weight. This is the type of this syndrome type that they had. So if they had any genetic mutations, different case presentations, how the case presented, if there's any family history, any lab studies were done. You have to know, like all this information. You have to know. You have to keep these in back of your head, like what you're trying to extract from each particular in each particular paper. So all the papers are on this side. These are all the papers here. This one. These are the papers, and I am like kind of expanding on my PICO here. This I'm putting the different data which I will extract based on the PICO, the population of my research question. My research question was I was trying to summarize data on Bartter syndrome patients, and my outcome was I was trying to look like where the patients are coming from, what were the treatment options given, what were the, for example, birth weight, what age they were born in, like what is the particular gender. Now what I did after that, after extracting all the papers, I just summarized the papers. I'm cooking the dish here, and I'm putting that in the real paper. This is abstract of the paper. Now what I'm doing is we had 48 case reports, 9 case series, this number of patients. We had majority of patients were under 5 years of age. They were predominantly males. I'm extracting that this particular point here. This particular point here. I'm extracting this particular is what is the gender of patients. Gender from all the patients. Extracting, then I'm putting that into the paper. Same thing will happen here. This was exactly testing all the type 1 were 37% were like KGM. This is the type 3. Type 2 were this percentage. I'm just collecting like from data extraction sheet. If you can see, I'm looking into different types here. This one. Obviously, like not every paper will give us everything. Like for example, the genetic mutation part was not given in this particular paper. The diagnostic test performed was not given in this particular paper. They are like if the disease was confirmed through a clinical diagnosed, or it was confirmed through genetic based testing, it was not given in this particular paper. So whatever information you have to summarize there. For this type 1, type 2, I'm just summarizing this. After that, I'm just putting in this percentage of types, this percent of this type, this percent of this type, 50% where we presented with poly, right? These are different presentations that these particular paper, like these particular patients presented with. I'm summarizing this from this data extraction sheet into a final paper. So this is the patient presentation. I'm seeing, like, for example, how many presented with polyuria. For example, I'm counting this complication. I will see this systematic. This one is the polyuria, this one is polyuria. Now what I'm doing, I'm summarizing the paper from my data extraction sheet. I'll summarize the paper. Polyuria. This is a summary. That's what we are like. Come from the start. This is a summary of papers. Right. This was our prisma diagram. That they're doing like it. Not a very clear picture that they uploaded. The same thing that we will follow the same process here of the title and abstract in the vertex screening. So this one also for the data extraction part. So this will be the core of like for example this process up to the data extraction part. This will happen in majority of reviews. Majority of reviews will do this. This part. They will format a search strategy. They will pull out papers. They will remove the duplicates. They will do the screening. They will do the quality appraisal. They will do the extraction. As I was saying here. So what happens in narrative reviews? They usually do not do any systematic process. So for the systematic process, you have to go through quality appraisal. You have to give them, for example, this particular paper. They will talk in the as for the papers, we have methods. We have a abstract section first of the paper. This will give us like a brief summary of the paper. This is the abstract section of the paper. Then we move the introduction of the paper. What is the paper about? What they're trying to say and what they're trying to prove. Then there is the method section. This method is an important systematic reviews. This differentiates it from a classical narrative review. Narrative review, you can do anything. You can upload papers anywhere. You don't have to talk about what databases is used. You don't have to talk about what search terms that you use, what search criteria you used, what were the ranking criteria, action criteria. You don't have to talk about anything. You just have to pull out papers. You have a narrative, and you will prove that. You will say we are saying this is a narrative. Apples are curing cancer. You will randomly pull out papers from anywhere, and you will randomly summarize them, and you will present your findings. That is running the narrative review, not the systematic review. You will have to give like there's a robust procedure here. You have to give like I use this particular search terms. Like they have given, I think they have given the particular search terms that they are giving here. The search strategies they have put in different databases. This is a full search strategy they have given. Number of databases they have taken everything. This is why it's called a systematic review. They have formed a system. They are moving into a system. So who built this system? These are those Prisma guys. They use a Prisma checklist. So Prisma checklist says, for example, if I can pull out the Prisma checklist from this particular paper, this is a Prisma checklist from this paper. Right? So you will have to fill this Prisma checklist to prove that you have systematically gone through a process and you answered your research question. So if anyone will follow my process, he will get to the same conclusion that I have gotten. Like if I am saying from my process, from my systematic review, the apples are curing cancer. and I am following the Prisma system. I am following this checklist. So I will have a protocol first. We will get in the protocol. I will have eligibility criteria. I will form a FICO. I will whatever do. I will form an inclusion exclusion criteria. For example, they will talk about the inclusion exclusion criteria. They will talk about everything in the method section. They will talk about the search strategy first. How they came out with the search strategy. They connect account of Prisma guideline. We searched in this number of databases. We put in this is the inclusion criteria. So they are only pulling out papers throughout the year 2020 May first. So they are putting in this search criteria, they are putting in this search strategy. And as they've explained in detail in the supplementary data. So what will they are also register the protocol in Prospero. We'll get into that. The search selection criteria, what were the inclusion exclusion criteria here for selecting a paper while going to screening phase. So while going to screening phase, they had a particular inclusion criteria, exclusion criteria. So whatever they're building, you need to have an expertise behind the subject first to build an inclusion exclusion criteria. You need to have, for example, a particular disease happens only in young, like small babies, infants, for example, less than 5 years of age. So obviously, I'll be excluding all the papers which are talking about our that I'll be putting in the injection criteria. I'll explain the injection criteria in my method section. That's what I'm doing. Now they will talk about the data extraction part. The two authors independently. That's why they're talking about independently two authors extracted data to prevent bias. There's an Excel. They're putting everything into Excel. They're building the data sheet, the extraction sheet, which I showed you about the borders into the patients. They're the same thing. After that, they will count the quality appraisal. There are different checklists. They are using this particular NIH quality appraisal checklist. So if I go into NIH, they have a checklist. These guys have different checklists for different research designs. So they're using NIH on this checklist. They mainly have cohort studies, observational studies, cohort study. So they are assessing on the basis of this. Same thing will happen for the quality appraisal part. We will make a table. Two people we will first author, second author, and we will bring in the third author to check the reliability. Same thing will happen there. So moving into method second, the quality appraisal part, data extraction part. Quality appraisal, data extraction, and then after that, extracting the data, then analyzing the data. The same thing, the data analysis part, this will be the calculation thing. So the same thing that I excluded, for example, I had different genders. Yeah, the male, female genders thing, this one. So what I did, I summarized this different softwares you can use to summarize everything. For example, out of 118 patients, I have this number of this gender, this number of this gender. All that mathematical calculation is explained in this part, data analysis part, the statistical analysis part, in the method section. After that, they move into the results section. Same thing will happen. Same with they're giving the Prisma diagram. They're giving whatever tables they have, risk assessment. These number of papers were all good quality, these were of bad quality. And then doing some analysis on the papers there. The data extraction part. Systematic review. And now we move into this was the systematic review. We have summarized, like, we have narrative reviews, we have literature reviews, we have systematic reviews. The systematic and narrative review will follow a system. Narrative will follow no system. We'll just bring up because we can answer this first question. In systematic review, we will have to follow a system. We have to follow the Prisma guidelines for that. Now, after systematic review, we will move into the meta-analysis. So what happens in meta-analysis is what we will do here is the basic meta-analysis that we do, or the comparison meta-analysis. What we do, for example, we have two particular treatments for some disease. For example, let's say for the same cancer thing, on one end we are using apples, huh? On second end we are using oranges. So there is a lot of evidence which says oranges cure this particular cancer. There's a lot of evidence which says apples cure this particular cancer. So what we'll do is we'll compare these two. We'll put these, we will extract whatever data we need from all the paper, whether related to which are proving that apples are curing the cancer. And same thing will happen with the oranges. Now we'll compare these two. How that will happen, I will come to that. How the comparison will happen. Same thing will happen is we will have to have a PICO here. More importantly, we will have to have an intervention comparison for the PICO, because we are putting in the comparison, we are comparing something here, right? The mechanism will compare two different things. Systematic review is not happening in the systematic review. Systematic review is just about I'm summarizing the evidence and putting it out there. What is the new thing on a particular disease, on a particular research question. That was having a systematic review. In meta-analysis, I will prove something like some doctors are saying apples do a good work of curing this particular cancer, but some doctors are saying oranges. I will pull in data from all the papers which are talking about apple. I will pull out data from all the papers which are saying same thing for the orange, and I will compare them now. And I will give my analysis on this basis if the apple ones are correct or the oranges are not correct. Same thing will happen here. These are mostly present in the forest plot. Like for example, if I go to an example, we have a paper, for example, this is a dental paper. So what they are doing, they are using BSM. This is a bone substitute material. So what is happening here? They're talking about dental implants. They are using this particular material versus not using this particular material in dental patients. So whatever dental procedure they are doing, they are putting in implants. They're using two types of materials here: BSM versus non-BSM, bone substitute material versus not using that. Now if you can see, the PICO is if we build a PICO from here, we will have dental patients with the implant thing, and we have intervention with BSM, the bone substitute material, comparison not using this material. And our outcomes in this particular papers are, for example, the outcomes that they have discussed, for example, in this particular paper on the basis of implant failure, if there was implant failure or not, using BSM versus not using BSM. What were the oral complications or these different outcomes? It's a vertical bone resorption or different kind of outcomes. Like you need to get expert in this particular field to know what outcomes you are looking for. The same thing will happen here. I will extract the data from they have particular studies here for oral complications, for example. This what these comparisons are doing, like they are just summarizing these comparisons on forest plots. So there are simple plots, like they have pie charts to summarize some data. Same thing happens here to summarize this comparison, to show this comparison between two interventions or two particular interventions. We use forest plots. Same thing will happen here. I will build a data extraction sheet for this one also. The data extraction sheet, I will come to the data extraction sheet. What I will do is I will do the same thing here. I will extract my data with respect to what were the all the complications here in using BSM. This part in using BSM, versus not using BSM. So this is the total population which use the BSM on order 9. In this particular, this one is a trial. This one is a trial. This one is another trial. They will be talking about like all these course studies or these trials, whatever these are. So whatever they will in these particular trials, they have taken out the data based on whatever complications they had. So they saw 3 complications here. 3 events happened in this particular trial in BSM patients. In non-BSM patients, same thing that they're calculating, and they are plotting that on a forest plot. All these plots are using, there are different softwares for this. There's Ravman, there's JASP, even R, and there are different softwares out which can do this. You just have to collect the data from different papers. You have to put these in this software, and what you can do after that is okay, you can show this on a forest plot. Same thing happens here. The events percent of the total patients in this particular, like for example, the apples, they are oranges. So we had 27 patients which took apple, and only 3 had a particular complication. 0 complications, and they are plotting in this, and they just giving us a mean kind of risk ratio. So what they are saying is favors non-BSM. So this particular paper is saying that there is a risk ratio, there's an increased risk ratio as summarized, which favors the non-BSM, using the non-BSM material. So they were giving us a particular finding of this. Same thing for this soft tissue aesthetics. Same thing for this one. They're just building the outcomes now. They're going to different. They have taken out um, different data from whatever papers they have, and they have plotted those on a forest plot. This will be a meta-analysis. Same thing. We'll do the comparison. This is a simple basic form of meta-analysis. We compare the 2 different options. After that, we can also go into network meta-analysis, which are a bit complex from the main meta-analysis. For example, we know we have 5 different options for curing a cancer. We have apple, we have oranges, we have banana, we have pineapples. So we have data, we have other data which are proven. We have data which proves A to B of curing cancer. We have a direct relationship here. We have a direct relationship from this. We have a direct relationship from this. So when meta-analysis, we compare A and B, apples and oranges, apples and banana, apples and pineapple. We cannot compare like 4 different options. We can only compare 2 different options. This thing happens in network meta-analysis. What we can do is we can compare these 2. We can compare indirectly these 2 because we have a direct comparison of this and this. Now we can do an indirect comparison of A and B. That will happen with this particular outcome. This decision is a bit complex. We should not go into that one. So that was about the meta-analysis. After that, we directly go into the building the main manuscript. Before that, I will go into the protocol thing and the Prisma checklist. We have already talked about the Prisma checklist. We have to talk about the protocol before starting any kind of systematic review, any kind of meta-analysis. It's not required for these narrative reviews, as I was telling that we have no guidelines around the narrative reviews. While doing systematic reviews or meta-analysis or any kind of reviews which are higher form, we need to have a protocol first. We need to say, like, for example, what we are trying to do, and we will register that protocol in a particular database. Like for protocol registration, we have OSO or we have Prospero. What we do in Prospero, for example, we will go in. I'm not sure if they have given us or this paper. So whatever the meta-analysis they were doing, they're registered before doing the meta-analysis, before doing anything. They registered a protocol somewhere. They registered, for example, a blueprint of their whatever they're trying to do in a particular website. Like they have registered this had a Prospero. They're taking a registration number there. They will definitely have a protocol attached somewhere. Maybe elementary material they have given us. This is the search strategy. So they're putting different search terms in different databases. This is PubMed, Sinhel. This one for Escobar. This one for Scopus. They're all saying different search strategies in different databases. This is some data, and I'm not sure if they're also going to set Prisma checklist here. Same thing. They're telling, like, for example, each particular question from Prisma checklist, they answered this on page number 1. So the page number 1 will talk about this particular point of Prisma checklist. So I'm not sure if they have given us a protocol. They're just giving us a Prospero ID here. We can go into Prospero and we can directly check for this ID and we'll get a protocol. So whatever they were trying to do in this particular study. So these things usually take time. These things take around, I would say, at an average of 1 year to complete one systematic review. So this is a process. What we do is we list a protocol here. So this will be done at the start. I have a research question. I will put in a protocol. What the protocol ensures is that I'm just putting it out there. For example, I am doing this particular systematic review. There is just like a notice board, notice board to whole world. Like I'm doing this thing. They will give us, like, for example, a basic. This was the review question. They will do this. They will include this type of studies. This is a protocol thing. These will be their main outcomes. This is how they will do extraction. They will do this bias like this one, and they will synthesize the results like this one. They gain everything, and they get all the information, whatever is required. Right. This was about the prospero thing. This protocol thing. And then after that, everything I will summarize into a paper. The paper will have the abstract, and have the introduction to the question. It will have the methods, whatever the method that I had, whatever the findings that I had, the results section, and that is a discussion section. The last part, where can I find? Where can you start? I would definitely say that for starting systematic reviews, I would definitely use AI for this. I'm starting to look into AI also. For example, before doing any kind of systematic review, look for different research questions. Look for mentors first. Look for different mentors first. That is the first thing, because mentors is very important to go through. Like, you need to have someone in the background who really knows about this stuff, who really knows like how like all this thing works. You need to have mentors. Another thing is to look for research questions. You will have to do different narrative reviews, scoping reviews, whatever reviews are out there. You have to say whatever data is out there. You will have to have a expert basis on doing any kind of review. We will have to have a research question. All those things are made easy by AI. Like, you can ask questions to ChatGPT, for example, to do anything. Same thing will happen in ChatGPT. You can now also build search strategies in ChatGPT. That was the other thing that I was talking about. Search strategy. You don't have to go through all this mess in the search strategy thing. I was talking about here, like, for example, the other thing, the third part. What I can do, I can go to ChatGPT. For example, this particular thing, I put this particular thing in for this paper. For example, we had that dental paper. So it gave me a kind of a search strategy for dental paper, which I can put in different databases. Would I use this if I was a beginner? No. Like, I would have to, at least I would have a basic knowledge of what this thing is talking about. After that, I will move into copying this into a database, or copying this search strategy into putting in different databases and pulling out my papers. Same thing will happen here. So this one is for people. I would definitely use AI here. Definitely use AI. And these were kind of old methods, right? We used to use, like, for if we have a narrative on we have a lots of narrative on some topic, there's a high chance that we can build a systematic review on that. Same thing with scoping though. So scoping review is just systematic review minus the quality appraisal part. We will not check the quality of papers at this point. Scoping review just gives us if there is a scope for systematic review or not. As simple as that. So what we used to do classically before the AI thing, we used to read different papers, narrative review, scoping reviews. So if there is a scope for a systematic review on a particular topic, or what we do, we will particularly check the introduction section of the narrative review or that scoping review. We'll check the limitation section, or we'll check the conclusion. The authors often talk about these things in limitation section. We had limitation of this, or we are concluding with this, and there is a high chance of getting a systematic review on this. We need more papers to build a systematic review. So you can check the different sections in these particular papers to see if you can find any if you can find any research question in this for you to do a systematic review. And there are 3 golden rules from my side for like any kind of systematic review. Your research question has to be strong. You need to know like what you're talking about. You can just pull out research questions on anything. You need to have expertise like at least in a particular subject for which you're going to do systematic review or any kind of review. Any questions you have, any problem you have in any systematic, any method, any step, use the second rule from my fault, that all your answers will be answered, all your questions will be answered in the systematic reviews that are out there. Read this different systematic meta-analysis. All your questions are answered, already answered in systematic reviews that have been done. And the third part will be that you need to build a strong team. A strong team is a key thing here. I have teams like, for example, we do systematic reviews in 2 months. I have teams which do systematic review in 2 years. So that is the, you need to balance between the teams. You need to have a strong team, like they are dedicated team. And these are the three golden rules. And the thank you slide, and you can reach out to me on Gmail or Twitter.